Hello everyone. Here we'll be discussing more numericals from electrostatics chapter. Right? Yeah. Sorry for the in the previous video the PDF was really blurred, so this time I got another one, and here we'll be discussing numericals. Okay. We discussed some MCQs from this electrostatic chapter, electrostatic, electric potential, and capacitance. So let's discuss some numericals. Yeah. So find the first question is find the dimensional formula. The thing is you read the question, you take your 2 minutes and you first solve it. Okay. Otherwise there is no point. Right? So find the dimensional formula of epsilon naught. Okay, this is a one mark question. You first try. Okay. You pause the video, then try, then let me know. Like check the answer with me. Find the dimensional formula of epsilon naught. How to solve it? Simple. We know F is equal to what? We know F is equal to K Q1 Q2 by R square, isn't it? F is equal to K Q1 Q2 by R square. So F is what? Sorry, K F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Right? Just a second. Okay. So now if I take epsilon to this side, epsilon naught is equal to 1 by 4 pi F Q1 Q2 by R square. Okay. So what is the dimension formula of F? MLT minus 2 Q square. This is Q1 Q2 means Q square. That means AT square. R square means L square. Okay. And if you solve it, how much you will get? This is M minus 1, L minus 1, T minus, so T plus 2, A square, T square, L minus 2. Okay. If you do it, M minus 1, L minus 3, T 2 to 4, A 2. Okay. This should be your dimensional formula for what? Epsilon naught. Alright. This is a dimensional formula for epsilon naught. Okay. Next question. A charge of 1 coulomb is placed at the top of your college building. Alright. And another equal charge at the top of your house. Take the separation between the two charges to be 2 kilometer. Find the force exerted by the charges on the each other. How many times of your weight is this force? Straightforward question. Nothing is there. Okay. Nothing is there in this question. A charge of 1 coulomb. Charge of 1 coulomb is placed at the top of your college building. Another equal charge at the top of your house. 1 coulomb. Separation between them is 2 kilometers. Okay, force exerted on each other. Force is what? Simple. K Q1 Q2 by R square. You have everything. You have K 9 into 10 to the power 9. Q1 is 1 coulomb. Q2 is 1 coulomb. R is 2 kilometer. You have to convert it into meter. That is 2 into 10 to the power 3 meter, and just put it here. You will get the value. Okay. Next question. Um, Next question is you solve this one. Okay. The answer of this question will be 2.25 into 10 to the power 2 Newton. Okay, 2.25 10 to the power 2 Newton. Next question. At what separation should two equal charges, 1 coulomb each, be placed? 1 coulomb each be placed um, so that the force between them equals the weight of a 50 kg person. At what separation should two equal charges, 1 coulomb each? Okay, two charges, 1 coulomb each. This is one charge, 1 coulomb be placed so that the force between them equals weight of a 50 kg person. This is R. Force between them is equal to weight of a 50 kg person. What is the weight of a 50 kg person? Weight means what? Weight is equal to mg. Okay. So 50 into g. G is what? What is the value of g? G is 10, for example, or 9.8. G is 9.8. So this is the weight of a 50 kg person. This should be equal to what? Force between two charges of 1 coulomb. So K Q1 Q2 by R square. K Q1 Q2 by R square. Alright, now put the value of K Q1 Q2 by R square. And you have to find what? R square. And from then you can calculate R. Alright, is it clear? Okay, you try this question. The answer will be 4.29 into 10 to the power 3 meter. Don't expect me to solve it completely. I just gave you the idea. What separation between, okay, I will do it again. See, there are two charges, 1 coulomb. Separation between them is R. So the force between these two is equal to what? Weight of a person who is 50 kg. So 50 into weight means what? Mg. Weight doesn't mean mass. Okay, 9.8. Equal to what? Equal to the force between them, that is K Q1 into Q2 by R square. Okay, so R square is how much? K value is 9 into 10 to the power 9 divided by 50 into 9.8. This is R square, so you can find R easily, isn't it? You can find it, right? I hope so. Yeah. Next question. Next question, let's see. 4 number is over. Number 5. Find the electric force between two protons separated by a distance of 1 Fermi. Again, same question. Force between two protons separated by a distance of 1 Fermi. Two protons here. What is the charge of proton? Same to the charge of electron. Separation is 1 Fermi. What is 1 Fermi? 1 Fermi is 10 to the power minus 15 meter. Okay. Just a simple calculation will be used. Okay. Number 6. Okay. Two charges, this and this, are placed at a separation of 10 centimeter. Where should a third charge be placed such that it experiences no net force due to these charges? You read this question and try. You have 2 minutes. Two charges, 2 in 10 to the power minus 6, 1 in 10 to the power minus 6 are placed at a separation of 10 centimeter. Where should a third charge be placed such that it experiences no net force due to these charges? Okay, two charges are there. Two charges are there. Okay, two charges is around what charges are there? 2 into 10 to the minus 6 coulomb, 1 into 10 to the minus 6 coulomb. Alright, distance is 10 centimeters, 0.1 meter. Let the charge, okay, we need what? There is another charge, okay, there is another charge here, suppose Q1, Q1, for example, at a distance x from this one. So this one will be what? 0.1 minus x, because the whole distance is x, 0.1. If this one is x from here, and 0. Then it will be 0.1 minus x from here. Okay, so it's saying the total force will be 0. If you have read the question, the net force is 0. It experiences no net force. So what will be the total force on this charge? F. This is 2 into 10 to the minus 6. That means 2 microcoulomb. 1 into 10 to the minus 6. That means 1 microcoulomb. So force on a Q1 because of what? For example, force on Q1 because of this is, for example, okay, leave it, 2 microcoulomb is equal to what will be the answer? K Q1 into 2 microcoulomb divided by what is the R? R is x square. Force on Q1 because of 1 microcoulomb is equal to K Q1 into 1 microcoulomb divided by 0.1 minus x whole square. Isn't it? Isn't it? Yeah. which is what? The net force is 0 on Q1. Okay, net force. Suppose this is your Q1. These are two charges here. This is x distance 0.1 minus x. Net force on Q1 is 0. That means the force in the right side equal to the force in the left side. So I can write force on Q1 because of 2 microcoulomb is equal to force on Q1 because of what? 1 microcoulomb. If if this is you, two friends are pulling you in the same opposite direction with the same force, then you will be at rest. You won't go anywhere. So that means what? Two forces are equal. That's why I'm writing it here. Two forces are equal. Alright. So just equate the forces. What are the forces? Yeah. KQ1 into 2 by x square is equal to KQ1 into 1 by 0.1 minus x whole square. Okay, KQ1 cancelled out. So the answer will be 2 by x square is equal to 1 by 0.1 minus x whole square. So 2 into 0.01 minus 0.02x plus x square is equal to x square. Okay, so 0.02 minus 0.4x plus 2x square is equal to x square. Okay, so I will simplify it x square minus 0.4x. See, these things I'm doing fast because these are basic things. I'm not gonna stop for this. This is if you do this, you have to solve it by x is equal to what? Minus this one minus b plus or minus b square minus 4ac rule. 0.4 plus or minus b square, that is 0.16 minus 4ac, that means 0.08 whole divided by 2. Okay, if you solve it, you will get it what? X is equal to, you will get as is equal to 0.0586 meter. Okay, this will be the answer. You have to solve it. Okay, yeah. So the concept is what? What is the concept? The numerical we will calculate, no problem. What is the concept? If there is a charge inside, we have to find the distance. We will separate the distance this way. This is the x and this is the total distance minus x. And we will find forces between these two and equate them. That's it. Okay. That is the concept that we have to use in this type of questions. Right? Okay. Next question. Suppose the second charge in the previous problem is minus this. Locate the position where third charge will not experience a net force. This one is for you. Exact same kind of question. Homework. Okay. Number 7. Exactly same kind of thing. Number 8. Two charged particles are placed at a distance 1 centimeter apart. What is the minimum possible magnitude of the electric force acting on each charge? Again, what is there in this question? Two charged particles are placed at a distance of 1 centimeter. What is the minimum possible magnitude of the electric force acting on each charge? Can you tell me? Again, read the question, please. Two charge particles placed at a distance of this. What is the minimum possible magnitude of the electric force? Okay, see. You would be thinking there is no charge given. How can I calculate this? What is this? Two charges, distance is 1 meter. Minimum possible, minimum possible force between them. So force formula is what? F is equal to K, K1 Q2 by R square. R is given, K is known. Q1, for force to be minimum, what should also be minimum? Q1 Q2 should also be minimum. Why? Because force is directly proportional to Q1 Q2. So if these two are minimum, then F will be minimum. Right? Right? So what is the minimum charge we ever know? Tell me. Tell me in the comments. What is the minimum charge? Charge is quantized. A Q is equal to NE. This is the what? Q is the integral multiple of electronic charge, charge of electron. It should be like this always. N is equal to 0, 1. So minimum charge is what? 1 e, isn't it? E. You will say it's 0. No, no. Charge must be there. Na? 0 means chargeless. E. So E. So Q1 is equal to what? E. Q2 is equal to E. Okay. Just put it here. K E square by R square. We know the value of E. 1.6 10 to the minus 19. Put it. R we know 1 meter. K we know 9 into 10 to the power 9. Okay. That'll be it. Right? Got it? Yeah? Okay. This is one. Next question. Estimate the number of electrons. Estimate the number of electrons. Number of electrons in 100 gram of water. 100 gram of water is given. Sorry. Estimate the number of electrons in 100 gram of water. Alright? And how much is the total negative charge on these electrons? Okay. Estimate. Remember the question? Okay. 100 gram of water. 100 gram of water. Alright. Number of electrons in 100 gram of water will be what? Hmm? Water is mass of water. Water is first of all H2O. So 2 plus 16, that is 18. Alright, 2 plus 16 is what? 18. Okay, isn't it right? Okay. Now what? Hmm. Okay. Number of molecules like H2O, number of atoms here. 2 plus, this is 8, that is 10. Okay. 2 plus 8, that is 10. So, mm, number of electrons in 100 gram of water. Okay, 100 gram of water, that will be 10. That is this one into your 100 gram divided by the mass. Okay, molecular mass, right? That will be what? If we calculate, this will be 55.95 number of electrons. Okay, okay. Is it correct? Is it correct? So this is actually okay. Now number of electrons. No, actually we have to multiply 6.6 to 023. Alright. Number of electrons in 18 gram of water will be how much? 6.023 10 to the power 23 into water, that is 10. Okay. 2 hydrogen and 8 like oxygen, that means 8, right? Number of electrons, because electrons, huh? There are electrons, 2 electrons in hydrogen, 8 electrons in oxygen. So this into 8, 10, right? That will give me 0. Into 10 to the power 24. Okay, this one. Now number of electrons in 1 gram of water. 1 gram of water is how much? The one we got divided by, sorry, 20.8 divided by 18. So we need what? Number of electrons in 100 gram. 100 gram will be 6.023 10 to the power 24 by 18 into 100. Just the unitary method we did. If you calculate it, it will be 3.334 10 to the power 20. Right? That will be your answer. Okay. Next question number 10. Just read the question. Such a long question. Read the question and try to do yourself. Okay. Just try to do yourself. These questions are a bit tricky. Suppose all the electrons of 100 gram water are lumped together. to form a negatively charged particle, all the nuclei are lumped together to form a positively charged particle. If these two particles are placed 10 centimeter away from each other, find the force of attraction between them, compare it with your weight. So first read the question, you write the question first, please. Otherwise, if I explain, the question won't be there, you won't be able to understand. Please write the question. It will take 1 minute to write the question. If you don't write it, you will waste your next 10 minutes in understanding. So better write one for 1 minute. Okay. Pause the video, write it. Till then I will be solving it. So this is a tricky question. You just first try to understand, then you will write. Okay. So first of all, molecular weight. Hmm, molecular weight is how much? 18. We just did. Molecular weight of water. That is 18, isn't it? 2 plus 16. Okay. Number of electrons present in one molecule of H2O. One molecule of H2O. How much? 10. Isn't it? H2O. Number of electrons. 2 here plus 8. 10. Okay. So, if you couldn't understand the previous question, now you can understand I think this one. 18 gram of water has how many molecules? Has 6.023 10 to the power 23 molecules. We know it. We have studied this in chemistry. Okay. Alright, molecules. But how many electrons? 10 electrons are there. So we'll multiply 10. Has how many electrons? 6.023 10 to the power 23 into 10 electrons. Is that right? So this is 18 gram. 1 gram will be 6.023 10 to the power 24. This is because divided by 18. Now 100 gram will be 6.023 10 to the power 24 divided by 18 into 100. Okay. Okay. So we know atom is electrically neutral, isn't it? Atom is electrically neutral. That means what? That means number of protons is equal to number of electrons. So this is the number of electrons, right? So this will be the same as number of protons. Alright. So number of protons will be how much? Same 0.6.0 to the 10 to the power 24. This is 26 because 100 is there. Divided by 18. Alright. Now charge of proton will be how much? This is number of electrons, number of protons. Okay. Charge of proton, charge formula is what? Q is equal to Ne. N is what? Number of protons is what? This one. So just put it 6.023 10 to the power 26 divided by 18 into 1.6 10 to the power minus 19 coulomb. This is the charge. Okay, this is the charge. Charge of electron is also this much. Okay, charge of this is QP. QE will be what? Again, same thing 6.023 10 to the power 26. Okay, 18 1.6 in 10 to the power minus 19 coulomb. Right? So, what is the question now? Let's see. We did everything. What is the question? If these two particles are placed 10 centimeter away, find the force of attraction. Find the force of attraction now. Simple. So we did all the hard work. Now we just have to find the force of attraction. Now what will be the force of attraction? F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So 9 into 10 to the power 9 into these two values we have got as QP and QE. You just put 10 centimeter. That means 10 into 10 to the power minus 2 meter square. That would be the answer. Is that right? Is that right? Okay. Yeah, that's the correct answer. You'll get the answer as if you calculate, you will get it as 2.56 into 10 to the power 25 Newton. Alright. So this was your number 10. Okay, so 10 questions we discussed in this session, and we'll discuss more in the upcoming sessions. Okay, thank you very much.